Okay, let's go ahead and get started. So last time we met, we looked at your project presentations. So everybody did really well. FedEx was impressed with at least some part of all of the groups, all the designs. So I've got them. I'm looking through them. I'll give each group feedback on them. It'll just take me a little while to get through them, but I'll try to get those back by the end of the week to you. Also, I think everybody turned in their individual sketches, so I'm going through those too right now. But overall, everything looks really good there. Our next FedEx presentation will be, I think it's about a month from now. It's a week or so after spring break. And for that presentation, instead of showing just sketches and concepts, we'll be wanting to show functional prototypes. So today we'll start talking about prototyping. And kind of my plan is, so this week we will, today we'll talk about prototyping in general, and in a little bit we'll focus somewhat on graphical user interface, the kind of stuff that you're doing for your project, and the kind of stuff that's the most common when we design interfaces. Then on Thursday, we'll look at specific tools for developing prototypes. We'll try out a few of them. We'll talk about different options and technologies that you can use in your FedEx projects and in general for prototyping those. And then after that, next week, week before spring break, we will do a in-depth look at using web technologies to design an interface, and so that everyone at least will be able to design a functional interface kind of from scratch using a web browser. And then after that, we'll look at some more specific and applied examples of different interfaces, things that aren't just GUIs and clicking and pointing before spring break. And then you'll have, I think, a week after spring break before FedEx presentations, and you'll have all of that time to get the prototype that you want to show FedEx ready. So, talking about prototypes, defining what a prototype is in general. So a lot of times, not just in human-computer interaction, not just in software, not just in computer science, there's the idea of a prototype. And in general, a prototype is something that is meant to represent part of a final product or thing that you're going to be building. It's a kind of a rough draft or a first look at proving something. So there are a couple of, well, there are quite a few different definitions that are offered in human-computer interaction. I pulled these two from Interaction Design, the textbook. And so they both kind of say that, a prototype is really whatever you need it to be or whatever you want it to be. And the main point, I think, kind of I looked at several definitions of a prototype and just knowing from prototypes that are built, the main takeaway is prototypes have to be interactive in some way, at least for our needs. I can't think of a possible time where we would build a prototype that the purpose wouldn't be to use it in some way, or to see how a user is going to interact with it. So as far as what the specific purpose of a prototype is, in a lot of cases, it can be something like proof of concept, right? So to give you an example, the lab I work in, we work on a robotic therapy dog. It's kind of like a stuffed animal robotic dog. And one of the things that we looked at early on was how do we get the tail to wag? How do we do that and without creating like a hard plastic enclosure and all of that? And so like a prototype in that case that I built was a cable pull system that would wag a tail. And that's all that we built was this tail system. And it doesn't show the whole system, which is the dog. It doesn't have any aspects, but really it was just a proof of concept that would even work before we tried to integrate it in. Another reason you might build a prototype is that you want to clarify part of an interaction or look closer at a requirement. So you may narrow in on one specific thing within your interface or your system that you're developing. You also might want to just understand in general what's the user's flow going to be like when they're using the system. So we've done sketching, and you can sketch out every possible interface that a user would see, but until you put those in a sequence and you have the ability to sit down and click through them and move through them, you don't have the full story really. And so prototypes can either be a broad thing that covers like your whole final product, represents all of it. It can be just one little component of it, or it can be a combination of that. And so there's this idea that the functionality can differ. So you kind of have the breadth of your system, and your prototype can either can go to any depth of actual functionality for any component in the system. So this is a concept that's usually called a T prototype, and the idea is that you might build like some really basic things for the whole system, but then like whatever you're really interested in looking at, you're going to build out that whole piece of it. And an important thing about a prototype is that for the most part, it's considered throwaway. It's something that's not going to be used for your final product. And it's something that may change so drastically that whatever prototype you've built, you just have to set aside and start over. As time has gone on and tools have gotten better, and people have narrowed in and have jobs building interfaces and very specific things, we do have ways of building prototypes that we don't throw away. We can do that, and we'll talk about that and the trade-offs of that. So one of the things about prototypes that is kind of important is the fidelity of the prototype. So generally, it's low fidelity to high fidelity. So I'm going to show you an example. This is a robot that at my undergrad university that we were looking at building. And the idea was it was going to be a telepresence robot. And this was like 2011 or something. And so, it's just going to be a robot that has a base, drives around, has basically an iPad on it, it can move around and do some things. So in terms of, we wanted to find out, how doable this was, what that would look like. And so this is just like a really simple, 3D render just of like what the shape might look like in general. This is just a really quick diagram of how we're going to prototype it out. And I'll show you just some pictures of kind of like a first prototype here. This is just something that's built, out of just like wood that you buy at a hardware store. It's got the rough shape. In this case, we were concerned with weight and the motor system and how that would work. So, this doesn't have any of these nice curves or aesthetic feel or plastic or anything. But it supported what we wanted to do here was to test this motor drive system. And so you can see another thing with prototyping is it's usually not meant to be pretty. It's meant to be quick and to study something specific. So in this case, these are all off-the-shelf components. So this is just a single board computer you can buy off the shelf. battery, the motors, and wheels are off the shelf. This thing that controls the motors is actually a hardware board that comes with its own API, and it's super simple. You just write like 2 lines of code, and you're up and running with that. And you can see, like, we didn't have a lot of details. Like this is just wired in and taped on here, and I think I have video. So the thing we're testing is the movement of it. So these are omnidirectional wheels. And so you can see, like, even in this case, obviously the robot would not be used with an extension cord hooked to it, but point is to test the wheels and then that kind of thing. Anyways, so that's just an example. It's a hardware example, but it kind of gives you the spirit of a prototype. So it's important to distinguish between a product prototype and what's called a service prototype. So service prototypes are basically more of where we're going to be as HCI focused, and that just means that it's going to involve the user and their interaction with it, whereas a product prototype may not directly be focused on that. Another way to view prototypes is kind of as a filter. So there's some research looking at viewing prototypes as filters to look at specific areas of interest when you're designing something. So these are just kind of 3 rules or principles that became pretty popular in the HCI community. And they just describe what we know about prototyping and what tends to be the case about prototyping. The main point of prototyping is that you want a simple form. You want to do it quickly and cheaply. You don't want to invest a ton of time and money into it. And you want to look at specific areas of your design space. And so here's a table that kind of just looks at some of the variables that you could explore. And so the idea being that you can fix some of these things or not really put much effort into some of these if that's not what you're interested in, while you vary or look at the others. So in this case, maybe you care mostly about the appearance of something, whereas you don't care so much about the behavior of it or how it's actually functioning. In a lot of cases, like you see test systems that have dummy data in them, so the actual fidelity of the data is not that important. And so you can imagine a lot of other categories. These are just some of the primary ones that tend to show up. So talking more about fidelity. So low fidelity prototypes tend to be the most distant from the final product's look or function. So they're still trying to approximate that product or some aspect of it, but this is where we're talking about things that are hand-drawn, that are on index cards, that they're not anywhere near what the final product is going to be. Or like the robot you saw, right? It didn't look anything like what you would expect it to look at the end. It's just focused on a certain aspect. So it's important with a low fidelity prototype, we're pretty much going to say that's never going to be part of the final product. There's no place for it. It's just not at the same level of what you're wanting to produce. So it's used for exploration, and then some examples are hand-drawn sketches and like using index cards. And so yeah, I have a video, and this is just an excerpt from a video that Google put out about rapid prototyping. I think it's about a year old, and so I've just clipped out part of them talking about a low fidelity prototype that I think is pretty good. So I'll play that.
In addition to sketching, another low-fidelity option is paper prototyping. Today I'll cover how paper prototyping can help you think through key user interactions, use color more purposefully, and visualize elevation and shadows. And let me give you some practical paper prototyping pro tips. As you can see with the sketch that Miriam created, it's easy to visualize the user flow, but it's a little bit more difficult to understand the user interactions between the screens. You can use your paper prototype to simulate interactions. For example, if we look over here, I've pre-created some paper prototypes, and we can explore what happens when I click on an individual button. Here we have the floating action button, or the quantity, and we can actually have it drop down. And see what happens when a new screen appears and we're looking at the checkout cart. We can also select the address, and a pop-up window will appear. To avoid carrying around your paper prototype from meeting to meeting, record these interactions with your phone. Or you can create an animated GIF by taking a few stills and throwing it into Google Photos' Auto Awesome feature. It's just easier to share your ideas with people that way. Another pro tip is to print out existing screens. Instead of redrawing all the common elements over and over, the goal here isn't to test your arts and crafts skills, but to explore the interactions and natural transitions between the screens. And since we're working with paper, you can also explore different principles of material design, such as color, elevation, and shadow. Paper prototyping can help you think through your purposeful use of color, because as a practical paper prototyping pro, you'll want to reuse the colors throughout the app. Not only is that easier, but when this translates to your final product, it will reduce visual noise for the user, making navigation much easier. And because we're working with physical materials, be sure to make note of how the layers form shadows. Of course, we have the x-axis and the y-axis. With material design, we're encouraged to consider and make use of the z-axis, an elevation of each sheet.
Okay, and so you can see some aspects that she touched on there. Being able to basically like make a component and then reprint that and manipulate it by hand. And so this can be really useful. It does seem kind of silly sometimes to have it all in paper form and to have these things scattered and moving them around. But it can actually be fairly straightforward and simple and helpful in kind of playing and exploring what you can do with a design. If you do have components that you can physically just move around and play with. Now, this kind of idea can be taken a lot further. You can conduct entire user studies with a low fidelity prototype. You can basically have these different screens and things, and you kind of act as the system. And so a person looks at this paper screen and they like touch the thing you want, and then you kind of the next thing in there for them. And there are all different levels of that. I mean, you saw kind of the clever thing here with the little sticky note folding down to be a drop-down menu. You can get creative and do all kinds of things like that. And so that's kind of the lowest end fidelity of a prototype. And the important thing is it's still interactive. It's not just a static sketch, and it's not just like a series of sketches saying, click here, then this happens, then that happens. Because it's really important to put yourself where the user is going to be, to know what that experience is going to be like. Because it can kind of be, it can be a little bit deceptive to draw out an entire system and then not use it, not be directly in there, but looking down on all of it. So on the other end, we have high fidelity prototypes. So they look and function a lot like the final product will. They are kind of the best for like a product video, for example. So if you wanted to pitch an idea for an application or some piece of hardware that you're going to make, you'd want a level of fidelity that's very high. So like, all of the failed Kickstarter products usually have videos that look pretty good, and none of those things exist. And these are just high fidelity prototypes of what it would be. So it's really good for conveying the concept. And we'll talk a a little bit later about concept videos and kind of pitching how a system works to a user or a target audience in a short amount of time. High fidelity prototypes can also be really good for testing usability and technical issues. So these are at the level that the look and function is what we think the final product, how it would look and function. And so you can actually find more usability issues, you can find technical issues that may arise. And these are more easily incorporated into a final product, or at least pieces of them might be. So when we start to do high fidelity prototypes, although it's not recommended practice and it's not the most common practice, you can definitely make high fidelity prototypes using the same infrastructure, the same code, same frameworks that you would a final product. So examples of this are, like if you're going to build an iOS app or something, you might go ahead and do your prototype in Interface Builder in Xcode. Maybe you don't hook up the APIs or the data feeds or whatever the final product will have, but you're already in that native system. And then any of the modern prototyping tools, a lot of them are considered high fidelity. So I'll talk next time about a lot of the specific high fidelity prototyping tools that are available. There are a number of them out there, and we'll try out a couple of them, and then we'll just kind of compile a list of them. So Google, in that series of videos that we watched about paper prototyping, so they have a segment on what they call digital prototyping, and so this is similar to the kind of prototyping tools we'll look at. And so they choose two very specific ones, but we'll go ahead and watch this. It's a little bit longer. I think it's like 6 minutes. But this guy will go through these two tools and show how they do layout and then some of the interactive elements using this software to mock up an interface that they're building.
Digital prototyping is the process of exploring an idea by building an interactive experience. Explaining abstract ideas in words can be tough. By creating an interactive design artifact that other people can experience themselves, your ideas become real. Digital prototypes are very helpful when you're pitching an idea, trying to explain a design detail to an engineer, or running user studies to validate your designs. Best of all, they don't require you to know how to code, which makes it fast and easy to explore many different ideas. In a way, digital prototypes are a lot like building models that architects create. An architect creates a model because it gives their client an idea of what the finished building will look like without hiring a construction crew and breaking ground. We use digital prototypes to build experiences that look and behave like the final app without using costly engineering time. Over the last few years, we've seen a lot of new digital prototyping tools enter the market. They each have their own unique set of features and priorities. Some tools focus on helping you build out the basic flow of your app, while others are more geared towards exploring small interactions. Today, we're going to take a closer look at two of these tools and see how they can be applied to our work. To give some background, our team is working on a fictional e-commerce app and has produced sketches and mocks showing the different screens. These artifacts have given the team a pretty good idea of what we're trying to build, but we wanted to have something that could be shown to stakeholders or used to test with users. I created a digital prototype to demonstrate the basic flow of our e-commerce app. As you can see, we have the home screen of our e-commerce app, and I can do things like scroll through the product feed to go shopping, and I can come up here and look at this carousel of different products, and I can horizontally scroll, and I see this clock here. Let's say I want to look into this clock and find out more about it. I can simply tap this card, and we'll transition to the product detail page, where we have a description about what the product is, and we can also take the action to add it to our cart. So by tapping this Fab button, we'll get a toast here that confirms that this Swiss railway clock has been added to my cart, and I can go back to the home screen. So to make this prototype, I used a tool called Principle. I'd like to show you a few of the features that made it easy to create it. Don't worry about understanding everything I'm doing. This isn't meant to be a tutorial, but rather to expose you to the possibilities of this tool. So here we are in Sketch, and we can see we have the static versions of our designs. Now we can import them into Printable by switching over to Printable and clicking the Import button. And now you see that the designs we had in Sketch are now present in Printable. This is really great because each design object that we had to control over in Sketch is now available inside of Printable. So you can see inside the layer list, we have access to all these different cards and different content pieces. We notice in the preview that we can't scroll anything. So the first step to making this prototype feel a bit more real is to add the ability to scroll. The way I do this is I'll click the content group, which is just this section right here. And under the vertical drop-down, I'll simply select Scroll. So now when we head over to our preview window, you'll notice that we can scroll the content vertically. And we can apply the same kind of thinking to this card carousel here, which we want to scroll horizontally. So we'll select the card carousel, and then under the horizontal drop-down, we'll switch it from static to scroll. So as you can see, when I make that change, it updates my preview automatically, and so now we can test out scrolling. So we can scroll down, and now we can also scroll across. So our prototype's starting to feel a little more real because we have scrolling enabled. But now we need to figure out a way to get from this initial screen to the product detail page. So we're going to talk about how to add a tappable target that transitions to a new screen. So what we'll do first is we'll select the card that we want to make tappable. And in this case, we're going to select our clock. And then we can click this little lightning bolt, and it'll show us a list of events that we can listen to. And we just want a basic tap, so when you tap this card, it will transition to the next screen. So this artboard is our detail page, so I'm dragging, and then I'll just release, and we'll have a basic transition. So now let's try this out. When I scroll down and scroll over, and then I click the clock, you'll notice that it automatically switches to this new view, and it did a nice little transition of the clock graphic to go up. And this all happened automatically, which is a really nice feature of Printable. So now that we've created one tap target, let's go ahead and do another one to make it possible to add this product to our cart. So again, I'll select this Add to Cart button, or Fab, and I'll click the lightning bolt again, and then I can again choose tap, and I'll just drag it to the next artboard. And what this will do is it will make us transition to the screen where this confirmation toast here will appear. So when we test this out, I can click this button, and now the toast appears. And this confirmation is great, but the last thing we need to do is make it disappear. So for it to feel realistic, it needs to come into view, tell the user that they've successfully added the item to their cart, and then it should disappear. So here we are on our page, and when we click this, you'll see that the toast comes up, and then it disappears. So the way we're doing that is we can add an automatic transition to the artboard, right here, auto, and when it's done animating, it will switch back to the previous state. And if we click on this transition up here, we can see in our animation panel that we can control the duration of the toast using this property here. And so what we can do is we can make this longer, and when we go back and test this out, you'll notice that it takes a little while for it to come up, and it's a slower transition. So to fix that, we'll just drag it back to where we had it at about a third of a second, and we can see that it animates in, and then it animates out. And the way we have it pause on that screen is we have this other animation drawn out to 2 seconds. And I just want to point out that as I'm making these changes in here on this app and using the preview, it's also updating live on my phone at the same time. So if I, again, shorten this duration here, we'll notice that it also works on the phone. I can set that back. And there it is. So with a little work, we were able to quickly get a feel for how our app will work and have an artifact that can be used to test with users or communicate transition ideas with other members of the team. We've only scratched the surface of what Printable can do, so if any of this seems useful to you, I would encourage you to visit www.principleformac.com to learn more. There are many other prototyping tools that can be used to achieve similar results. In our next video, my colleague Partik will demonstrate prototyping and interaction using a tool called Form.
As you've seen, Chris created a basic prototype of navigating through our e-commerce app and adding an item to the cart. Using Chris's prototype made the team question if there might be a more efficient way of adding an item to the cart without navigating to the product detail page. To begin my exploration, I started off by working with the screens we had and thinking about how we could incorporate this feature. I wanted to create something more interactive and gestural since we're working on mobile. My initial thought was to open Sketch and design the flow of this interaction there. But it's hard to convey motion, gestures, and the overall experience of this interaction in a static format. Since the scope of this work is narrow and gesture-based, I decided to use Form to create an interactive prototype. Form is a node-based prototyping tool for iOS and Mac. Here's the homepage of the e-commerce app. You can tap and hold on a card to make it draggable. Then you can drag it over the cart icon to add it to the cart. Once you let go, the carousel at the top shifts over, indicating that the radio card has been added to the cart. This prototype clearly communicates my design to others. Form also lets me share this with anyone by simply shaking the device. Let's take a look at how you would build something like this. You start by connecting a series of patches together to create functioning prototypes. Patches are little chunks of logic that can be connected together. A patch can take in a value through its inputs and then output the modified value. For example, let's take a look at how panning the radio card works. Starting from left, we have the pan gesture, which is connected to my radio card image. I use this patch to add the ability to pan things around. The gesture outputs the X and Y pan, which correspond to the position of the touch on the screen. So to move the card, let's say on the X-axis, I take the X pan output, put it through a spring patch which animates the value, and then input that value into the X position of the image patch, since I want the card to follow the position of my touch. That's a quick overview of Form. If you're interested in learning more, check out the tutorials at relativewave.com.
Okay. So, as you can see, it gets a little complicated there, designing things like that. So it kind of quickly escalates from, making some boxes and groups into having timelines and having all these attributes, then having a node-based editor where you're connecting events and trying to sequence things. And so it kind of still holds that it's tough to make high-fidelity prototypes without coding, basically. So, like, whenever he wanted to do the, he was adding something to the cart and he wanted the little bar to pop up at the bottom and go away, that was all done through transitioning between different, static images, basically. And it becomes a little bit difficult to manage all of that. And so, in that sense, sometimes it can be easier for people who are familiar with programming or that can think better in that way to invest the time in, actually programming something, actually, building a UI that would be built on the same kind of technology that you would build the final product with. Because for most of us, some of these advanced tools that allow us to make a high-fidelity prototype, the time we need to invest in learning those tools is going to be high. And at least for me, every time I've used one of these tools, I will ultimately get to a point where there is something I want to do that I can't. And whereas if I'm just using code and I'm, maybe I'm just grabbing libraries and components that other people have made, as long as, I'm doing that, if I get to something and there is no off-the-shelf component, I can just write the code I need and plug it in. When you're dealing with these prototype generating kind of software, that's not always the case. So when we look at them on Thursday, we'll look at some of the limitations of them, and they're definitely getting better and better. So I don't want to dissuade you too much from using them. I think they're really useful for some things. But as you get into more nuanced parts of your interface, they're not always the best. So the other point is that it's not really just a binary thing. There's not just a low and high fidelity prototype. This is a spectrum. And so it kind of, whatever your specific project is, your specific system that you're building is. That domain is going to influence it. The team that you're working on and what they're comfortable with is going to influence how you prototype. And your development plan will definitely influence, the prototyping decisions that you make. While it is kind of this continuum, one thing that's interesting to note is that medium fidelity prototypes are generally evaluated less favorably whenever they're studied. And if you think about this, it's kind of intuitive. So if you give someone a low fidelity prototype and you show them like, oh, here's this index card and I'm going to switch it or whatever, the way they evaluate that system, they're very aware that this is not what that final system is going to look like. And if you give them a high fidelity prototype, they're going to evaluate a system that is at the level the final product would be at. If you put them in the middle somewhere, oftentimes people aren't that sure what things are prototype and not real and what things are in their final state. So that can be a little bit confusing. And so we'll talk about doing evaluations and studies later, but that's something that you've got to be careful about. So choosing, when to use which fidelity. And when we've kind of covered this, basically you want to start with your low fidelity whenever you're really brainstorming and just kind of throwing ideas out there quickly. And then you want to move on to the higher and higher fidelity as you close in on a design that you like. So here's another, and these are just various HCI books and kind of, giving you the advantages and disadvantages of each type. So if you look at the low fidelity prototypes, obviously the advantage there is it's low resources, low time commitment, and you can make a bunch of them quickly. But it's a disadvantage in the sense of it doesn't capture the actual thing you're trying to make usually. It can capture some aspect of it, but it's never fully the system, and there can be a lot of surprises later, even if you've used the low fidelity prototype. High fidelity prototypes, they get closer to the amount of resources and effort to build a real system. And so that can be an extreme disadvantage, certainly if you're in a brainstorming phase and you're not locked down on what you want to do. But it can also be an advantage in terms of reusing that, and the testing that you do with it will be much more accurate. So that kind of leads us to this general idea in HCI research, kind of up until current day, that when you're making a prototype, programming is kind of a bad idea. And the reasons for that is that it's a significant amount of time and effort usually. So to build the code and the framework to make your interface. And that can discourage you from experimenting with things because you're just trying to get something working reliably. Certainly discourages rapid changes because of the time investment. And actually, you can get kind of attached to the thing that you make. The more effort you put into it, the more time you spend with it, it's just kind of you'll grow to be attached to it. And so it can be hard to throw those away sometimes. And then this for me is the worst one here. So there's a chance if you make a prototype and you program it and it works on a system like it would work, the final product, same system, someone in the real world, I guess you're a manager usually, in the academic world you're an advisor, will see this thing working and they'll be like, okay, good, we've done it, it's good. And so then it gets pushed into production, like it's in use now. And it was never meant to be. Like, you hacked it together, right? It's ugly, and there are things that shouldn't be there. And then, so it gets pushed into production, but then it might even get worse because you might have to support it once it's in production with all of its hackiness. And then also, you're never going to get time to fix it because, it works. You already did that. That's good to go. You need to work on the next thing. And this will inevitably cause you embarrassment and shame. Because you will have this horrible, hacked, ugly thing out there. And even though maybe people can't see that side of it, you know, when other people come along later to try to add to it or use it, you're just going to be sad that you're the one who wrote that. Now, on the flip side of all of this, programming is a good idea. So these are kind of the cases when it is a good idea. If you have really well understood constraints, if you know the domain you're working in, you know we're going to use this technology, it's going to be on this device, and we use these frameworks, and you know there's not a lot of exploration that's going to happen in terms of the technology. It's kind of an advantage to go ahead and use what you're going to ultimately end up with. Also, you need to really enjoy the programming and be good at it to the point of it's not causing you an excessive burden or amount of effort to create something that you might have to throw away or change drastically. And in some cases, if you can't support your needs in any other way. So this kind of comes up when you are developing things that are really specialized and there's not a good way for any of like the prototyping software or anything off the shelf to really do it, and you need a fidelity where it has to be programmed. Now in this case, a lot of times you can just program that one piece that you don't have from anywhere else. And that's a good way to do it. And if you're someone who enjoys rewriting your code or your application, and you truly are willing to throw away everything, and I mean everything that you did previously, then yes, there's no reason not to go ahead and do this. So personally, I find that the third or fourth rewrite for me is when the thing actually looks good and works. So I do like to rewrite things. And so a lot of times I won't necessarily do a high fidelity prototype in a mock-up tool or anything like that. I'll go from sketches to code, and that's fine. But it's also, I wouldn't do that if I were working in a technology that I wasn't familiar with. I would stay on the safe side. So it's a balance, and it really depends on the project. So considerations for building prototypes in general. We talked about conceptual models in the past, and what's important with the prototype is interactive. That's probably the most important thing about it. But the other thing is that it's going to be the thing that allows you to be the user. And you really need to be the user. It's kind of just, it's a night and day difference if you don't do this versus do this. So you want to think about, the person who's going to be using it. What do you want that experience to be like, and how are they going to understand the product? So when we talked about conceptual models, we talked about metaphors, and that's a big part of it. So you want to be able to leverage people's existing knowledge and understanding of the world and processes. So you want to be able to say, this system, lets you do whatever, just like this other thing lets you do that. You want to be able to hook into existing knowledge. And so you want to be able to develop analogies and metaphors for the product that you're making for that system. And then you want to be able to understand kind of the concepts within that domain, the task, and the relationships between them. And we've talked about this in the past. And this was the example that we used in the past, this metaphor of a calculator. And in this case, it's just a graphical interface that looks like a physical calculator. When we start to think about the user and how they're going to use the app and how it's going to solve a problem for them, it's kind of important in cases like what we're doing with FedEx, for example. The things that the FedEx design team or FedEx managers tell us are important to them, that's one set of concerns. That doesn't always represent what the user might be concerned about and what might affect their experience. So as somebody who's working on the user experience in HCI, you've got to get you've got to bridge those two groups. You've got to understand what they each need and where the problems are going to be. So there are several ways to do it. There's use cases, scenarios, user stories, storyboards, and we'll talk about each of them. But the most important thing is that you want to understand the functionality your solution provides, and you want to know what information is being used in your system. So what's the important thing that you're operating over? So just briefly to look at this. So use cases is a term it's usually thought of more of a software engineering world kind of thing. And basically, you're concerned with a specific actor who interacts with the system and what their goals are with the system. And it needs to be pretty specific, usually like a manager needs to set up an alert to do X or Y. And so when you look at a use case, you look at that whole interaction flow for that manager from their perspective, how they would accomplish the task. Scenarios tend to be more informal kind of narratives almost about, like you think about all of the users that are using the app, the goal they want to accomplish, and kind of set up a story of what might be going on in their world and what they're going to do with the app. And then walk through how that actually takes place. User stories, they're similar to use cases, but they're less from the software engineering world, but they're very focused on a specific user and their perspective. And it's a little bit broader in terms of how the system affects them, and it's not necessarily where a use case is a specific user with a specific goal and task. A user story is kind of that user's whole existence within your system. And then we have a storyboard, which is one way to kind of capture a scenario almost, which is just a sequence of events going on. And this is really similar to like if you ever look at, animated films being produced, you'll have, artists will draw frames kind of showing like, oh, this scene's gonna happen, then we'll move to this scene, and then this, and it's the same exact thing. It's a storyboard about how the app will be used, or how the system will be used. There's this idea of design maps. And the idea here is to kind of create a timeline, basically, of a user's interaction with the app and to document different things that they encounter on that timeline. So I have two examples. You can do them kind of, this is an example of it being in a wheel here. And basically, you've kind of got these different events that are happening. You can see that we're representing maybe the user's feelings of positive or negative as we go around this thing. And then there's some segments here of before, during, after. And I think this is about booking it's like a travel reservation system or something. And so this is one way to do it with kind of this circular wheel approach. The other approach is just more of a linear kind of a timeline approach. And so you can kind of use columns and rows to map this out. Okay, so let's move on to actually constructing prototypes. So we'll talk a little bit about hardware prototypes. I know we aren't doing hardware necessarily for your projects, but this is a big part of HCI, and it tends to just kind of grow more and more rapidly. So if you're doing hardware prototypes, the idea is to get up and running fast. And so a lot of times this can mean grabbing off-the-shelf items, finding something and transforming it into something that you can use. So lately, though, we've had the benefit of some technology. We can 3D print things really quick now and pretty cheaply. So if you're designing something that involves hardware, once you've learned to use like some 3D CAD software and some basic things like that, and there's a ton of it that's freely available now, you can be pretty comfortable designing a part, printing that out, if you have access to like a machine shop or something, you know, that's obviously something you can use. But the mechanical side of making a physical thing, for the most part, has gotten a lot easier in the past 10 or so years. And of course, you can use traditional means of just machining something with tools. And again, like this kind of prototyping can be very low fidelity or very high fidelity. So I think like the Palm Pilot maybe. The first version of it was like a block of wood, and they just kind of shaved it into the shape that they thought it might represent. So in terms of electronics, today we also have the benefit of having a lot of really easy to use, off-the-shelf, low-cost development boards. So things like an Arduino or a Raspberry Pi. And these are things that allow you to kind of do basic electronic things with basic components really easily. Low investment in terms of time. Once you've done it once, you get pretty familiar. And there's also an incredible amount of resources available for learning this kind of thing. So for hardware, you really want to use off-the-shelf components, and you want to iteratively refine it. So since I work in robotics, a lot of the prototyping I do is hardware. It is electrical stuff. We certainly do a fair share of software and interfaces, but the hardware stuff definitely is interesting. So I put a few pictures of thousands of them. So this is a robot that we made. It's a little kind of just robot meant to drive around in an environment, and it's got a night vision camera on it. And we're using it with SWAT teams. But the idea here is that it's super low cost because it's completely 3D printed. And all that it has inside of it is a Raspberry Pi Zero and a little camera and some batteries. But even with this, relatively simple kind of prototype, we go through a ton of revisions, and these may look all the same, but they are all slightly different in some way, and they're all printed. So here's kind of these are all off-the-shelf, development boards and just off-the-shelf battery cells. These are motors that are used in toys, real cheap off-the-shelf, and then the actual physical structure is something that we can just print pretty quickly. But what's nice about this is that you can make changes easily. You can try it out. With something like a robot, you really do have to try it out in a lot of cases before because we can model this whole thing in a CAD program and it looks wonderful. And then you actually manufacture it and you realize that you can't fit this in here because you put this thing first and now something blocks whatever. So thinking through all of these things, it's nice to have a physical piece of hardware to work with. And so that's a huge part of prototyping, is just being able to create something, find the defects, the parts that aren't going to work for you, and then fix that, create the next one, and keep refining that over and over until you get to something that's stable. And you can see so for example, this version of it, those batteries are literally trapped in there. So once it's sealed up, it's just kind of one-time use. And actually in the previous version, these down here are all different. We changed the back of it to have a slide-in mechanism with the batteries in it. And so that's just something that kind of goes, happens as you develop these things. So here's another example just to show you kind of how things iteratively change. This is for Therabot, which is the therapeutic dog robot. And in this case, you can see this is one of the bottom covers on it. But you can tell when we started this, we knew that we wanted some ventilation here. So we have just a grid of holes. And then as we began to work on it and see components and things, now you can see that it's got some very specific holes with some very specific shapes. meant for things. Also, you'll see like, so this one, you've got just these, open things, and then here all of a sudden you have now like a nice cross thing, because these all break whenever when someone puts force on the robot. And so it's little things like that that make prototyping incredibly useful for hardware. And I think equally so for software. It's really easy to see it in the hardware because you can physically break it and it doesn't work anymore. And so you have to change something. But it's definitely a critical part of designing a system. So for software prototypes, some specifics to think about. And we will spend 2 or 3 classes on these things. But in terms of software, you're often faced with using either software development kits, APIs, libraries, frameworks, or even just guidelines about a particular platform. So SDKs are pretty much a set of components or widgets that are given to you with the platform, whereas APIs are just kind of input-output specifications. A lot of times when we look at like libraries, so this might just be a collection of components or utilities that you can use in your project. Where on the other hand, you can also look at things that are more like frameworks, which they incorporate components and utilities, but they have specific rules about how you use them. And so a framework you typically need to learn a lot more and kind of conform your design methods to the framework. And then guidelines, we'll talk about these, but pretty much any major company, any major platform will have a detailed set of design guidelines on what they consider best practices, what they consider to be, illegal practices in their world and that they won't accept, and just generally have some rules for how the software should function. So specifically talking about visual user interfaces, like the kind that we have in our projects, there are a few areas to really focus on, and we'll talk about them over the next week or so in some detail. But these things are important for HCI, and we can't really just ignore them and work at a higher level. So like, for example, at the most basic level, anything with a screen on it, there's a whole graphics pipeline there. Things are being processed, pixels are being manipulated. There are, we have nice high-level constructs, like in an operating system, we have windows that we can move around. In any major system, they're going to have like a set of widgets, right? Like, if you want the user to select a file chooser dialog is something that just exists. You don't have to make that. And in any major system is also going to have different ways of doing layouts. And so we'll talk about different visual layouts. There are fixed layouts, which is where if you happen to be in a situation where you can assume that nothing will dynamically change, like you've got this many pixels by this many pixels and they're always all yours, then you can kind of do things in a very calculated way, a very absolute way. Whereas if you're building, a website that's going to be pulled up on a desktop and it's going to be pulled up on a mobile device and a tablet and a watch, and then maybe like the mobile device is going to rotate from portrait to landscape, you're going to have to think a lot more about layout. There's a lot more to it, and there are a lot of systems trying to deal with that, trying to cope with that, because you're in a situation where you're trying to understand what the user's environment looks like now, and it's changing, and what you need to do to make your application or system functional, but also still enjoyable to use, and that can be quite challenging. You also have to consider events happening. So, you can't assume that it's just going to be you can set up this environment and nothing else is going to happen. In some cases, a window gets resized. You've got to be ready for that. There's some network message, or the user does something to intervene, or they switch apps, or they come back. There are some resource constrictions. There are a lot of things to worry about, and you can't be completely blind to them because it does propagate through the user experience. So also input devices are kind of an interesting thing to think about. So specifically multi-touch is pretty interesting. And thinking about that when you design something, how you handle that. So having just a mouse and just a single pointer of interaction is relatively simple in comparison to having multiple touches. When you start to have things like pressure-sensitive displays, whether that's a stylus or just a touch pressure sensitivity, you get some added complexity there too. And a lot of these things, so kind of these top three areas, what people are seeing, the events that are happening, and the input they're giving, timing is important. Performance is really important because the more latency that gets introduced into these things can really frustrate a user. And so these are the cases where it pays to actually kind of understand the more low-level computer science programming side of things, but also have an awareness of kind of just the end user interface part of it as well. So we'll also talk about for visual UIs, kind of just how we divide that up into, obviously your software usually has something it's doing, some logic to it, and then it's also got an interface to get input and output. And so popular ideas, model view controller, there are a ton of variations of that. But the idea being to separate out the programming, like the logic that's actually, handling whatever your application does, the business logic usually, from the actual interface logic that might be controlling things like highlighting something when you hover on it or animating something. And then the controller connecting the model to the view. And so basically, we often get into a situation where we maintain a state of what the world is in our software, and we also have to give that state to the user. We do that through the view usually, and we want those to be in sync all the time. And there are a lot of ways they can get out of sync, so that's important. Also specifically with just traditional user interfaces, the ability to undo something is really important, and it's something you have to plan early for when you design a system, really. So if you haven't ever written software or something that has undo functionality, and not just the functionality like undo the typing that the operating system provides you, I'd encourage you to think a little bit about how you might implement undo, because that can be a little bit tricky in some cases. And we'll look at it in more detail later. We'll also look at, and this is mostly because of a lot of the FedEx projects deal with a large amount of data needing to be displayed or consumed at a time. And so there are some special ways to do that and to handle that. There are some UI principles that kind of change whenever you need to display a lot of data. And then we also want to talk about just data visualization in general, because a lot of the FedEx projects and a lot of projects, a lot of systems overall have an interest in kind of a historical view of what's happened in the system. And it's nice to be able to provide the user a visual that is, first of all, not deceptive about what's going on, but second of all, is actually useful and gives them some insight they didn't previously have. So being able to take a large amount of data and visualize that in a way that is helpful it's definitely its own field of study, and we will look at some of kind of the best advice in that area. And it's also an area that's grown quite a bit, and there's also a lot of you can find a lot of articles online, a lot of communities dealing specifically with big data visualization kind of things, because kind of as a society, we have been exploding with data recently. And so analyzing that data and visualizing it has become a bigger priority. And so that's a really good thing. But we'll look at all of these specifically over the next couple of classes. So next time we will look at development methods and tools. We'll do a quiz over prototyping. Should be pretty straightforward. Any questions before we're done? Okay. See you guys on Thursday.